Let's talk about how to mark and interpret Venn diagrams for categorical syllogisms. I've been encouraging you to look at Venn diagrams in a very particular way. That is, to assume that you're at some vantage point very high up in the air and you're looking down into buildings that have had their roofs removed. And because of that, you can see everything that's in these buildings. So from our vantage point, if we look into this green-walled building, we would see all the banjo players in the world that exist. And we look into the red-walled building, we'd see all the rednecks that exist. And in the blue-walled building, we'd see all the awesome people that exist. Now, what's interesting about Venn diagrams for us is we not only see everything that's in these buildings, we see where they are. So if we look into our green building and we see something in area 1, we'd say, well, that's a banjo player. But it's a banjo player that's not a redneck because it's not in the red-walled building. It's up here in area 1. It's also a banjo player that's not an awesome person, as if such a thing were to exist, because in area 1, we're outside the walls of the blue building. But if we look down here and we see something in area 2, we'd say, oh, wow, that's a banjo player that is also a redneck because it's in the walls of the green building and the red building. Anything here we see in area 7, though, that would be an awesome person, but it wouldn't be also a redneck or a banjo player because it's outside the red and green walls. Anything here in magic area number 3, anything there, it's actually in all 3 buildings because you can see all 3 circles overlap right here in area 3. Anything in area 3 is in the green building. It's also in the red building, and it's also in the blue building. So anything there is a member of all 3 categories. Now, what we're using these Venn diagrams for is to test arguments for validity. And of course, the way we do that is we take the premise statements of our categorical syllogism and we mark them in the appropriate areas to reflect what the Venn diagram would look like when we assume the premises are true. Right? That's the key assumption. We're assuming the premises of a given categorical syllogism are true, and we're going to mark the Venn diagram in a way that illustrates that. Because what we want to know is this. When I assume the premise statements of a given categorical syllogism are true, is it impossible for the conclusion to be false? In other words, does the conclusion statement then appear in the Venn diagram after I mark just the premise statement? Because if it does, that means it's impossible for the conclusion to be false when I assume the premises are true, and this categorical syllogism is valid. But if I mark the premises in the Venn diagram assuming they're true, and I don't see the conclusion statement illustrated by or reflected in that Venn diagram, then I know, oh my gosh, it's possible for the conclusion to be false, even when I assume the premises are true. So this argument is invalid. Okay, so we're going to mark the premises only. Never, ever, ever are we going to mark the conclusion because we're trying to figure out whether or not the conclusion follows by logical necessity from the premises. All right, so let's take a look at our banjo, awesome player, awesome people, and redneck argument. Okay, now when we have these 2 premises we have to mark, so we've got to figure out how to mark the Venn diagram using our shading and X's to reflect our 2 premise statements. And it doesn't matter the order that we mark the premise statements. Okay, so we can mark the first one or we can mark the second one. There's one exception to that though, and this is something worth writing down. Let's just say I chose to go start with the second premise here, some banjo players are rednecks. I have to come down to here to my Venn diagram, locate my banjo player circle, locate my redneck circle, and figure out where there's an area where there could be something that is a member of both of these categories. Where would there be something existing in both of these buildings? And you might, of course, point to area 2. Anything in area 2 would be a banjo player because it's inside the green walls, but it would also be a redneck because it's also inside the red walls. And you're right about that. But we could also mark something in area 3. And anything in area 3 is both a banjo player because it's in the green walls and a redneck because it's within the red walls. Okay. Now we get only one X. So where does the X go when I've got 2 possible locations to put it? And the answer is, well, I don't know, because anything in area 2 is as much of a banjo player as anything in area 3. And it's as much of a redneck in area 2 as it is in area 3. It's not more of a banjo player or more of a redneck because it exists in area 2 outside the awesome people category. These are equally members of banjo players and rednecks, okay? So the lesson here is this. When you're marking your Venn diagram for a given categorical syllogism, you always start with the universal premise if there's one present. Okay, so the argument, all valid categorical syllogisms are going to have at least one universal premise, at least one premise that starts with all or no, and that's the one that you mark first. Never mark the particular statement first. Okay, so now we want to skip back up to our first premise. All banjo players are awesome people. So I want to show that there are no banjo players that are not awesome people, because every single banjo player is an awesome person. So where are my banjo players? They're here in areas 1, 2, 3, and 4. If there was anything here in area 4, that would be a banjo player that is not an awesome person. And I'm trying to show that all banjo players are awesome people. So I know I'm going to have to shade in area 1. But I'm also going to have to shade in area 2, because anything in area 2 is a banjo player, but it's not an awesome person. And I want to show that all the banjo players are awesome people. Okay, so now I'm going to shade in areas 1 and 2. Another thing to take note of is that anytime you're marking a universal statement, a statement that begins with all or no, you're going to shade 2 areas, unless one area has already been shaded. So anytime you mark a universal, you're going to shade 2 areas. Now look what happens. I've shaded in my first premise, and now I need to mark an X for my second premise. Some banjo players are rednecks, and there's only now one spot where any of those banjo players that are also rednecks could be, because I shaded out area 2. We turned out the lights in area 1 and 2 to show that there's nothing in there. All the banjo players are in areas 3 and 4. So now I get to put my X in area 3 to show that some banjo players are rednecks. Okay, so now I'm done. I've marked my premises, and I'm going to look at my Venn diagram to see if it now also reflects the conclusion statement, some rednecks are awesome people. Is there anything that exists in my redneck building, the red building, that also exists in my awesome person building, the blue building? And the answer is yeah. This guy right here, he's not only a redneck, he's also an awesome person. And that's exactly what the conclusion says will be the case if we assume these premise statements are true. So this indicates to us that this is a valid argument. It's impossible for the conclusion statement to be false when we assume the premises are true, and that's exactly what this Venn diagram shows. We can also now check our work, because we could have made a mistake in the way we mark this Venn diagram. And the way we check our work is we go and we look at the form of the argument, and we can see we've got an A, I in figure 3. And now what we can do is we can turn to our inventory of unconditionally valid forms, look at under figure 3, and look at there, right there. So now I can be doubly sure that I've got a valid argument, because I've created a Venn diagram that proves it, and I've consulted my inventory of valid forms, and this form of argument appears there. So this argument is valid.